Welcome to the debate. Today we are taking on, well, the heavyweight champion of modern physics and science fiction. We are talking about the many worlds interpretation of quantum mechanics. But we are not here to talk about Marvel movies or, parallel timelines where you married your high school sweetheart or became a rock star.
No. Yeah, it is good to be here. We are looking at a much colder, harder question. We're looking at the actual machinery of reality itself. The question isn't, wouldn't it be cool if there were other worlds? The question is whether the strict logic of mathematics forces us to accept that those worlds exist, whether we like it or not.
Precisely. We are analyzing a specific, rigorous inquiry into the structure of time, geometry, and existence. The source material we're looking at today argues that the many worlds interpretation, or MWI, is effectively an act of ontological inflation. It argues that we have mistaken a map for the territory, and in doing so we've conjured billions of phantom universes that simply are not there. I will be taking the side of the source material today, arguing for a single invariant universe.
Right. And that is where I am going to have to stop you right out of the gate, because calling them phantom universes biases the jury right from the start. I'll be taking the opposing side. My position, and the position of many eminent physicists, I might add, is that these worlds are the inevitable output of our best equations. If you believe in the math, you have to believe in the worlds. You don't just get to pick and choose the parts of the equation you like.
Fair enough. That really is the core conflict here. Do we take the math entirely literally, or do we look for what is invariant? What stays the same regardless of how we choose to describe it? To kick this off, I actually want to use the opening image from our source material. It's a twist on a classic thought experiment.
Ah, the coin flip?
The coin flip, exactly. So you flip a coin, it lands on heads. You see it, you record it. Now imagine you possess the power to step out of time and look at the four-dimensional structure of that event. You see your past self standing there, getting ready to flip it.
This is a standard time travel setup. If I touch my past self, do I create a paradox? Do I explode?
Right. In the movies, yes, the universe implodes. But in physics, no. Because you and past you are just different segments of a worm, a long four-dimensional tube of biology stretching through time. There is no paradox because time isn't a room you just left empty. It is a coordinate that you occupy.
Okay, yeah, I follow that. This is the block universe idea. Past, present, and future all exist simultaneously as a geometric object. I am the worm.
Right. Now, the source material makes a really fascinating move here. It says MWI proponents make the exact same mistake as the bad time travel movies. They assume that for a possibility to be real, like the coin landing on tails, it needs a separate container to happen in. They think the universe has to, clone itself to make room for the tails outcome.
But see, that isn't an assumption. That is a result. When the coin is in the air, it is in a superposition of heads and tails. When it lands, the wave function, the actual mathematical description of the system, it doesn't just delete the tails part. It's still there in the equation. So if it is in the equation, where is it in reality? MWI simply says it is in a branch, a separate world.
And I am here to argue the position of the source material, which is that the universe is one invariant structure. That the tails outcome exists as a component of the wave function, yes, but it does not generate a sovereign, geometric world. The many worlds view adds content that just isn't in the math. It violates the basic standard of what we call physical reality.
And I am here to defend that literal reading. I am here to argue that this invariance you're talking about is a sort of philosophical straitjacket that you are trying to force onto a quantum reality. If the equation says the branches don't talk to each other, then for all intents and purposes, they are separate worlds. Denying them is just us being uncomfortable with how big the universe actually is.
Okay, let's get into the machinery then. I want you to give me the strongest possible version of the many worlds defense. Why do you think the math absolutely demands multiplicity?
It starts with the Schrödinger equation. I mean, this is the Rosetta Stone of quantum mechanics. It tells us exactly how a quantum state changes over time. And the key feature of this equation is that it is unitary.
Which implies what exactly for our listeners?
In simple terms, it means the evolution of the system is smooth. It's continuous. It perfectly preserves information. Nothing ever abruptly snaps or vanishes into thin air. The equation never says, and then half the possibilities just disappear.
We agree on the equation. It flows.
Right, but look at what happens when you measure something. When that coin interacts with the air, the table, and your eye, the system undergoes decoherence. The mathematical term for the head state and the tail state becomes orthogonal.
Orthogonal. That is the magic word here.
It is, because it means mathematically perpendicular. It means they stop interfering with each other. They act completely independently. If I'm in the heads branch, the physics looks totally normal to me. I see heads. But the tails branch is still evolving, totally uncoupled from me. It looks like a world. It acts like a world. It follows the laws of physics exactly like a world. So why are you twisting yourself into knots to say it isn't a world?
Because looking like a world and being a world are two very, very different things. My position following the source is that you are mistaking a description for an ontology. You are mistaking the map for the terrain. In physics, we have a gold standard for what actually counts as real. That standard is invariance.
You keep using that word. Break it down for me. Invariance under what?
Symmetry transformations. Let's look at Einstein. This is the crucial analogy the text uses. When Einstein was building special relativity, he hit a wall. Different observers moving at different speeds couldn't agree on reality. One observer on a train says that stick is 1 meter. Another, standing on the platform, says, no, it's half a meter. One says that took 5 seconds. The other says, no, it took 10.
Right. Time dilation and length contraction. Classic relativity. The faster you move, the slower time goes for you relative to someone else.
Exactly. Now, imagine if Einstein had done what the many worlds proponents do. Imagine if he said, oh no, they disagree, therefore there must be 2 different realities. There is one universe where the stick is a meter and a completely separate universe where it's half a meter.
Well, he'd have infinite universes for every possible speed.
Exactly. It would be absurd. Instead, Einstein asked, what is invariant? What stays the same for all observers? And he found the space-time interval. He realized that space and time are relative, but the 4-dimensional geometry is fixed. There is only one invariant object, space-time itself, and the observers just have different perspectives or slices of that object.
Okay, I see the parallel you're trying to draw here. You are saying the branches in quantum mechanics are like the length in relativity. They just depend on your perspective.
Precisely. The source material highlights this rigorously. The branching structure of the universe depends entirely on your modeling choices. It depends on how you choose to slice the system from the environment. It depends on your coarse graining, basically, how blurry your glasses are. If I change the mathematical basis I use to describe the wave function, the branches change, or they disappear entirely.
Wait, hold on. That is a massive claim. You're saying if I just use a different mathematical notation, the physical worlds vanish?
Yes. If you write the wave function in a different basis, say a momentum basis rather than a position basis, the nice clean branching structure dissolves into a mess of interference. A real object, like a rock or a planet, shouldn't vanish just because I decided to use polar coordinates instead of Cartesian ones. If the branches aren't invariant, they aren't fundamental. They are artifacts of how we describe the system.
I admit that is a powerful argument, but I think it proves too much. I think you are setting the bar for reality so high that nothing can jump over it except abstract math.
How so?
Look at a hurricane. Is a hurricane invariant? No. Its boundary is fuzzy. It depends on how you define wind speed. If you change your coarse graining, if you look at it molecule by molecule, the hurricane disappears and you just see individual particles. But if I told you hurricanes aren't real, they are just descriptive artifacts, you would tell me I'm crazy. They destroy cities. They are real.
Ah, this is the emergence defense. It is probably the strongest card MWI has.
It is a winning card. We accept tables, chairs, biological species, and hurricanes as real things, even though they are emergent and high level. MWI argues that worlds are just like hurricanes. They are robust, high-level patterns in the wave function. Why do you hold worlds to a stricter standard of reality than you hold a table?
That is the pivotal question, and the source material has a very specific answer. It comes down to the type of robustness. A table is stable under the theory's natural equivalences. If I rotate the coordinate system, the table is still sitting there. It is invariant under the symmetries of spacetime.
And branches aren't?
No, they are not. The text points out that branch structure depends on the foliation of spacetime. That is just a fancy way of saying how you slice time moment to moment. In general relativity, there's no single right way to slice time. If the existence of these worlds depends on an arbitrary choice of how to slice time, then they don't exist in the geometry, they exist in the index.
The index?
Think of a library catalog. You can organize books by author, or by title, or by color. Those are indices. They are useful ways to sort information. But organizing by color doesn't physically create a new library.
MWI mistakes the index, the branching, for the territory, the universe. It is a category error.
I am not sure I buy that category error dismissal. The decoherence is real. The suppression of interference is real. That is physics, it's not just filing.
Agreed. Decoherence explains why we see definite outcomes. It explains the appearance of a classical world. But explaining the appearance is not the same as generating a new sovereign universe.
Let's push on that sovereign idea, because this leads us to what I think is the most difficult part of your argument. The space-time dilemma.
This is where the rubber meets the road. You keep saying these other branches aren't real because they aren't invariant, but mathematically they are orthogonal vectors in Hilbert space. They are huge, complex structures. If they aren't in our space-time, where are they?
You just answered your own question. They are in Hilbert space. But Hilbert space is not a place.
Explain that, because physicists talk about Hilbert space like it's a real thing all the time.
Let me use an analogy. Imagine you go to a restaurant. The waiter hands you a menu. The menu lists all the possible dishes: steak, pasta, salad. That list is like Hilbert space. It contains all the mathematical possibilities, the vectors.
Okay.
Now, when you order the steak, the waiter brings you a plate of food. That plate is space-time. That is the physical reality. The MWI proponent looks at the menu, sees pasta and salad, and says, well, the menu is real, so there must be a real plate of pasta and a real plate of salad somewhere in the kitchen, even though I only ordered steak.
That's a little reductive, isn't it?
Is it? The source material argues that Hilbert space is an algebraic abstraction. It is a tool we use to calculate. Space-time is a geometric manifold. It has distance, time, causality, gravity. You can't eat the menu. MWI proponents look at the algebra, see these extra terms, and try to force them into the geometry.
But if the algebra describes reality,
The menu describes the meal options, but it isn't the meal itself. The source material calls this the light cone ontology argument. Just because two vectors don't touch in abstract math space, that's orthogonality, doesn't mean they generate two independent, metric-equipped spacetime manifolds. You can't just wish a new spacetime into existence because your algebra got a little complex.
But this puts you in a bind. If spacetime is fundamental, you're saying there's no room for the branches. But what if spacetime isn't fundamental? What if spacetime is emergent? That is the hot new idea in quantum gravity. Maybe spacetime emerges from the branching itself?
That is the other horn of the dilemma, and it is a sharp one. If spacetime is emergent, you have to show me the derivation. Show me the paper where someone derives multiple independent spacetimes emerging from a single quantum state.
We have derivations of spacetime from entanglement. Carroll, Ramsdonk.
We have derivations of a spacetime, singular. The current research suggests the quantum state generates one geometry. To say it generates billions of disconnected geometries is a hope. It's not a result. The source is very firm on this. The world's language imports spacetime manifold ontology without deriving it.
So it is a pincer movement. If spacetime is real, there's no room for the worlds. If spacetime is emergent, we haven't proven they actually split.
Exactly.
Let's step back from the heavy geometry for a second. I want to talk about the experience of the observer, because MWI solves a huge problem that your one invariant structure doesn't seem to touch at all: probability.
Go on.
If I am about to flip that coin,
I feel uncertain. I say, it's 50-50. In MWI, we have a way to explain this using decision theory. Since I will split into two versions, one seeing heads and one seeing tails, I should rationally bet according to the weight of the branches.
The Deutsch-Wallace argument?
Yes, it explains why we use the Born rule, the probability rule. It says a rational agent in a branching universe must act as if the probability is real. But in your one-invariant structure, the future's already fixed. The coin is already landed in the 4D geometry, so what does a 50% chance even mean?
The source material actually devotes a whole section to dismantling the MWI decision theory. It calls the argument completely circular.
Circular how? It seems pretty logical to me. I care about my future selves, so I hedge my bets.
But to make a decision about which branch I will be in or to divide your money between them, the branches must be countable. You need to be able to say, here is branch A, here is branch B.
And we are back to the framing problem.
We are. Since branches depend on modeling choices and coarse graining, there is no fact of the matter about how many branches exist. Are there 2 branches, 2 billion, infinite? It completely depends on how you look at it.
Why does the exact number matter? I just need to know the weight.
Because weight implies a distribution over a set. Think about a mountain range. How many mountains are in the Himalayas?
A lot.
But the exact number depends on where you decide one mountain ends and another begins. If you can't rigidly define one mountain, you can't bet on which mountain you are on. The source argues you cannot distribute credence. You cannot place your bets over a space whose topology isn't determined by the theory itself.
So you're saying I can't say I have a 50% chance because I can't even define I or chance without making arbitrary choices about where to draw the lines.
Yes, you cannot distribute credence over a space whose topology isn't determined by the theory. If MWI can't tell you exactly how many worlds there are without you arbitrarily deciding, then the probability math collapses.
That leaves us in a very strange place regarding likelihood. It feels like you're saying probability is an illusion because we can't count the buckets. But I have one final line of defense here: the closed universe.
The ontological ceiling.
Right. MWI proponents often say, look, all these branches exist in the wave function. They are all equally real.
Equally real. That is the trap.
Why is it a trap? It sounds democratic.
Because the universe is defined as the totality of being. There is no outside. If these other branches are real, they must be part of this universe. They must participate in the causal informational fabric of reality.
Sure, they are part of the universal wave function.
But if they are part of the same fabric, connected by the same laws, then they are not separate worlds. They are just differentiations of one world. You can't have it both ways. You can't say these worlds are totally separate and don't interact, and also say they are equally real parts of the same universe.
Unless universe is just a collection of non-interacting parts, like a bag of marbles.
But universe implies a unified system of relations. Space-time is a relation. Causality is a relation. The source argues that an outside container for the universe doesn't exist. It's like saying north of the North Pole. It is grammatically possible but referentially empty. If MWI requires these branches to be elsewhere, there is no elsewhere for them to be.
You know, hearing all this, it feels a bit claustrophobic.
How so?
Well, if your view is right, we are left with this one invariant structure, a single, static, 4-dimensional jewel. It contains everything that ever happened: the coin lending heads, the dinosaurs, the heat death, all existing simultaneously in a geometry we can't see from the outside.
Yes, a block universe.
In MWI, the splitting is a kind of birth. It is dynamic. New possibilities are constantly being created. The future is open because the world is literally tearing itself open to make room for it. In your view, the possibility was always just a fixed geometric feature we hadn't walked past yet.
That is the emotional core of the resistance, I think. We want the splitting. We want the open future. But the source asks a hard question. Is the universe here to entertain us or to exist?
The universe does not library itself for our convenience. That is the line.
Exactly. We are threads reading a text. Just because you haven't read page 200 yet doesn't mean the page is blank. It just means you haven't processed it. The source calls this view strange and beautiful, a universe that is one closed structure expressing infinite internal differentiation.
It is a powerful image. I will grant you that. Invariance is a hurdle MWI hasn't quite cleared. And the idea of ontological inflation, multiplying universes just to save our intuition about probability, is a very heavy price to pay.
It is the anti-Einstein move. Einstein unified. MWI multiplies.
However, I am not ready to fully let go of the orthogonal components. They are in the math. To simply say they are indexical feels like we are ignoring the ghost in the machine. But perhaps the ghost is just the rest of the geometry.
And that is the ultimate question we leave on the table today. Are we travelers hopping between infinite diverging roads, or are we a single thread woven into one invariant, eternal whole?
A thread in the tapestry or a traveler in the multiverse?
Thank you for joining us on this investigation into the structure of reality.
Until next time.
So, I want you to imagine this. You are standing in a perfectly quiet room.
Yeah, okay.
Maybe it is a library, maybe it is just your living room with the curtains drawn. There is a wooden floor right beneath your feet, and the air is just totally still.
Setting the scene.
Yeah, I really want to paint this picture. You have a quarter in your hand. You can feel the cold metal, the little ridges on the edge. You flick your thumb.
The universal decision maker.
Exactly. The coin spins. You see a flash of silver, it catches the light, and it hits the floor. It wobbles, it spins on its edge for that frantic second, and then it settles. Heads.
Right. A totally simple, mundane event.
The kind of event that happens a million times a day.
All over the world.
Right. But now I want you to try a mental exercise. I want you to imagine you can step out of that timeline.
Step out of the now.
Step out of the now and walk backward. Just 10 seconds. You are now standing in the corner of the room watching your earlier self. Let us call him U prime.
U prime, getting ready to flip that coin.
Exactly. You are the observer of your own past.
Yep.
A ghost in the room. You stand there and you know the outcome is going to be heads. But U prime, holding the coin, does not know that yet.
To him, the future is completely open.
Right. And to you, it is closed. Now you walk over and you reach out your hand to tap your earlier self on the shoulder. Here is the question. Does the universe explode?
The classic paradox panic.
Seriously, though. Does a paradox annihilate the room? Does the fabric of reality just tear apart because you were in two places at once, violating the timeline?
It is the ultimate sci-fi trope, the grandfather paradox.
Right.
This idea that the universe is this incredibly fragile glass structure that just shatters if the timeline is not kept completely pure.
But the answer?
The answer, according to the really heavy-hitting text we are covering today, is a resounding no. Nothing explodes.
The room stays quiet.
The room stays quiet. The coin still lands.
So why not? Why does the universe not care that I am violating causality?
Well, because the bodies, right, your body now standing in the corner and your body then holding the coin, they are not these magical vessels of identity.
They're just stuff.
They are just cellular structures. They are matter.
Right.
Just lumps of carbon and water separated by a coordinate.
Okay.
The only reason we think it is a paradox is because we are completely obsessed with this idea of time as a container. We think the past is a locked room we have left, and the future is a locked room we have not unlocked yet.
And if you try to go back into the locked room, you break the lock and the whole house collapses.
Exactly. But that container view,
Yeah.
that is the villain of today's deep dive.
It absolutely is. We are diving into a source text today that is going to hurt some brains, but in the best possible way.
Oh, yeah.
It is titled Universe 1 Invariant Structure, complete.pdf.
I will admit it is a pretty dry title.
Yeah, it sounds like a manual for a dishwasher or something.
It reads like a manifesto.
It really does. It is this intense philosophical and mathematical takedown of one of the most famous and romantic ideas in modern physics, the many worlds interpretation.
The multiverse.
Right.
The idea that every time I choose coffee over tea, or every time an electron spins up instead of down, the universe splits in two.
A whole new reality born just to accommodate your breakfast choice.
Precisely. And this text argues that that idea is not just wrong.
Not just a miscalculation.
Right. It argues it is a fundamental misunderstanding of what the universe actually is. It argues that we have mistaken our map for the territory.
So our mission today is pretty epic. We are going to dismantle the multiverse.
Brick by brick.
We're going to find out why the universe does not branch, why there are no parallel versions of you living better lives out there, and why the alternative, this one invariant structure, might actually be way more beautiful.
It is a massive shift. Moving from seeing the universe as a messy library of infinite books to seeing it as a single perfect geometric object.
I am ready for this. Let us unpack it.
Let us do it.
So before we get to the quantum mechanics, which I know can get heavy and we will break it down for you, we have to deal with our intuition first.
Always the hardest part.
Because I feel like I live in a container. I really do. I experience time flowing. Monday turns into Tuesday. The past feels physically gone. Why is the text saying that is wrong?
It is not saying your experience is wrong. It is saying your model of the experience is wrong. The author actually calls us secret Newtonians.
Secret Newtonians. I love that phrase. It sounds like a weird secret society. What does it actually mean?
It means that deep down, even if we know about Einstein and black holes and relativity, we still think about time the exact way Isaac Newton did.
And Newton had this very rigid view of time.
Very rigid and very intuitive. He saw it as a master clock.
Like a giant clock on the wall of the universe.
Exactly. A universal now that ticks at the exact same rate for everyone, everywhere in the cosmos. In that view, the past is a bucket that we have emptied, and the future is a bucket we are waiting to fill. It implies that time is a space. Like a hallway. You walk down the hallway.
And if I turn around in a hallway, I bump into things.
Right. If time is a narrow hallway and you try to go back, you collide with the past. Two solid objects in one space crash. That is where that grandfather paradox intuition comes from.
But physics destroyed that hallway a long time ago, did it not?
It did. Specifically in 1905, Einstein's special relativity took an absolute sledgehammer to the Newtonian hallway.
Einstein showed us there is no master clock.
Right. There is no universal now.
This is the hard part to wrap your head around for a lot of people. No universal now.
Mm-hmm.
Meaning my now is not the same as the now of a guy in the Andromeda galaxy.
Exactly. Now is a completely local concept. It depends on where you are and how fast you are moving. Time is not a container you sit inside. It is a coordinate. It is a direction you travel.
The source uses the astronaut twin analogy here, and I know everyone who listens to these kinds of deep dives has heard of the twins.
It is a classic for a reason.
It is. But I want to really drill into why this specific analogy matters for dismantling the multiverse.
It matters because it redefines the concept of separation. So let us walk through it. You have two twins. Let us call them Alice and Bob.
Standard operating procedure.
Always Alice and Bob. So Alice stays on Earth. Bob gets in a spaceship, flies at 99% the speed of light, does a massive loop around a distant star, and then comes back to Earth.
Okay.
When they meet up, Bob is physically younger. His beard has not grown as much. His cells have literally not divided as many times. His watch has ticked fewer times.
And we should clarify, this is real, right?
Yeah.
This is not just some math trick or an illusion of the mechanical clock.
It is 100% real physical reality. We measure it with atomic clocks on airplanes and satellites all the time.
GPS, right.
Yeah, if GPS satellites did not account for this time dilation, your Google Maps on your phone would be wrong by miles every single day.
Wow.
But here is the kicker, and this is the specific point the text makes. Did the universe split when Bob left? Did they create two different parallel timelines?
No, they did not. They are standing right next to each other at the end. Alice is old, Bob is young, but they are shaking hands in the exact same room.
Exactly. They just took different paths through space-time. One path was longer in time, which was Alice sitting on Earth. One path was shorter in time, Bob zooming through space.
Just like if you walked a straight line to the grocery store and I walked a zigzag.
Right. Our pedometers show completely different numbers of steps.
But we did not create two different grocery stores. We arrived at the same physical place.
So time is just distance in the fourth dimension. It is a measure of the path you took. It is not a container that holds everyone in the exact same moment.
So the text argues we have to fundamentally stop asking, what is the universe inside of?
Yes, or asking what time is it for the universe right now?
Because the universe is not inside anything.
That leads directly to this concept in the paper of the closure constraint.
The closure constraint. That sounds like a legal term, or maybe something from computer programming.
It is a logic term, and it is absolutely crucial for dismantling the idea of other worlds. The closure constraint simply means the universe is defined as the totality of being. By definition, there is no outside.
Okay, but my human brain struggles with that. I think in terms of boundaries. If I walk to the edge of the universe, what is past the edge?
That is the wrong question. It is a grammatical trap. The author uses the north of the North Pole analogy to explain this, which I think is brilliant.
Okay, lay it on me.
You can say the sentence, I am going north of the North Pole. Grammatically, it is a perfect English sentence. It has a subject, a verb, a direction.
Sure. I am walking north of the North Pole. Sounds fine to the ear.
But geographically, what does that sentence actually describe?
Nothing. Because once you are standing at the North Pole, literally every direction is south. You cannot go north anymore. The whole concept of north evaporates.
Precisely. North of the North Pole is a phrase that has syntax but absolutely no semantics. It describes nothing in reality. The author argues that the phrase outside the universe is the exact same kind of error.
It is a grammatical phrase that describes a void of meaning.
Exactly. So when many worlds proponents say there are other universes branching off from ours, they are effectively saying there are secret lands north of the North Pole.
That is the core argument. Now apply this to the physical reality of these other worlds. If they are real, where are they?
Well, usually in sci-fi or even in pop physics explanations, they say they are dimensionally shifted or orthogonal.
Or vibrating at a different frequency.
Right. But here is the ultimate test. Are they connected to us? Can we interact with them? Can I send a radio signal to the version of me that ate cereal this morning instead of toast?
The many worlds theory says strictly no. Once the branch splits, we are cut off forever. Decoherence separates us completely.
Then the author hits us with a really hard logic bomb. If they are completely causally disconnected...
Meaning they can never touch us.
Right. If we can never touch them and no force of nature can ever pass between us, in what sense do they exist?
They might as well be imaginary.
Right. If they have zero interaction with our reality, they are functionally non-existent. But, and here's the real trap for the multiverse folks, if they are connected.
If they're part of the same mathematical structure.
Yes. Defined by the exact same universal wave function, then they are not separate worlds.
They are just distant rooms in this world.
Exactly. You cannot have it both ways. You cannot say they are independent sovereign realities where completely different things happen, and also say they are generated by the exact same physics and part of the same global state.
So the many worlds are either fake, functionally non-existent, or they are just weirdly folded parts of the one world we are already living in.
Precisely. We should not call them parallel universes. We should just call them the universe. It is a single, complete object.
Okay, so philosophically, the container idea is a total bust. We have established that asking what is outside is a pure mistake. But we have to address the elephant in the room now.
Let us do it.
The many worlds interpretation, or MWI as the cool kids call it, is not just some stoner philosophy. It was not invented by a guy in a dorm room looking at a lava lamp.
No, it was invented by HANDS Everett III, a brilliant physicist at Princeton in the 1950s.
And there are actual Nobel Prize winners today, people vastly smarter than me who completely subscribe to it. They're not doing it because they like sci-fi movies.
So,
They say the math absolutely demands these other worlds.
yeah,
They literally say we are not adding the worlds, the equation puts them there naturally.
that is the absolute core of their defense. They actually claim to be the conservatives in the physics world.
Because they take the math literally.
Right. They say they are just reading the explicit results of the Schrödinger equation without adding any extra rules.
So let us look at that.
Yeah.
Because if the math says there are infinite worlds, I guess I have to believe it. The text breaks this down into two distinct parts, what everyone agrees on and the interpretive leap.
Right. So step one, the math. Everyone agrees on the Schrödinger equation. This is the bedrock formula that tells us how quantum stuff behaves. It describes the wave function.
And for those of us who have not taken quantum mechanics since, well, never, the wave function is basically a list of probabilities.
Sort of. Think of it as a complete mathematical description of a system's state. It is a mathematical object that contains literally all the possible information about a particle or a system.
Okay.
And the key feature, the thing every physicist agrees on, is that it evolves smoothly.
Unitary evolution,
Yeah.
that is the term the text uses.
Yes. Unitary evolution means the change is linear and completely reversible. It means information is never, ever lost. The movie of the universe never skips a single frame, and you can always rewind it perfectly. It flows like a perfectly smooth river.
Okay, smooth sailing so far. No infinite branching yet.
Step 2, decoherence. This is also completely agreed upon. This explains why we do not see blurry quantum ghosts walking around in real life, why a cat is either alive or dead, never both at the same time.
Because in the quantum realm, things can be both. Right. Superposition.
Yes. An isolated tiny electron can be spin up and spin down at the exact same time. But a cat is massive. A cat is made of trillions and trillions of atoms.
And those atoms are constantly bumping into air molecules, light photons, heat.
The environment.
Right.
That constant messy interaction with the environment leaks the quantum weirdness away. It forces the system to look classical to our eyes. It suppresses the quantum interference.
So decoherence is what makes the macroscopic world look crisp and distinct to our eyes.
Exactly. Everyone agrees on the Schrödinger equation, and everyone agrees on decoherence. The huge controversy, the actual fight, starts with what you do with the other parts of the math.
The parts we do not see.
Exactly. Imagine the wave function has two parts for you right now. Part A is you eat toast. Part B is you eat cereal.
I'm a toast guy.
So you sit down and you eat toast. You look down, you see the crumbs on the plate. You are clearly in Part A. The ultimate question of quantum mechanics is, what happened to Part B?
The old school Copenhagen interpretation, which I think is still the standard textbook view, says Part B just vanishes. Poof. Gone.
The collapse of the wave function. God rolls the dice. Part A wins. Part B is permanently deleted from the universe.
Which honestly feels incredibly arbitrary.
It is mathematically very ugly. The equation itself does not say to delete Part B. The Baire equation implies Part B just continues to evolve alongside Part A.
So the many worlds people look at that and say, hey, the math says Part B is still there. It is just orthogonal.
Which means perpendicular, unreachable.
But it is there.
Right. So they say if the math says Part B is still there, it must be physically real. There must literally be a physical version of you sitting somewhere eating cereal.
That is the Everett move. And our source text calls this the interpretive leap.
Yes.
But why is it a leap? It sounds logically consistent. If the math is there, the reality is there.
The source argues that this fundamentally confuses differentiation with multiplication. This is a subtle but absolutely devastating distinction.
Unpack that for me, because that sounds like the key to the whole argument.
Think about a lump of clay on a table. That clay is your universe. It has a very specific, conserved amount of mass. Now take your hands and squeeze it right in the middle so it pinches and creates two big humps.
Okay, I have the dumbbell shape now.
Right. Do you now have two completely separate lumps of clay? Or do you have one lump of clay with a shape that just has two parts?
I still have one lump of clay. I've not added any actual clay to the table.
Exactly. The Schrödinger equation simply rearranges the stuff of the universe, the probability amplitude. It changes the physical shape of reality. It differentiates the global state into a toast component and a cereal component.
But the many worlds interpretation looks at those two humps of clay and screams, look, two clays, two separate universes.
Yes. They are mistaking a change in shape for a literal duplication of stuff.
The text actually uses a thermodynamics analogy here that I found really, really helpful.
Right. The first law of thermodynamics. Energy is conserved. It changes form from heat to light to kinetic motion, but it never, ever multiplies. You do not get more energy just because you changed its form.
So if I have 100 joules of energy and I somehow split it into 50 joules of heat and 50 joules of light.
You do not suddenly have 200 joules of stuff.
Right, exactly. So why, the text asks, would you get more universes just because the wave function changed its shape? Why does mere differentiation suddenly become infinite multiplication?
That is a really strong point. It feels like getting something for nothing on a cosmic scale. I made a choice, so now there is a whole new massive galaxy out there.
It violates our deepest instinct of conservation. The text calls this mistaking the index for the territory.
Explain that phrase. Mistaking the index for the territory.
Well, we index mathematical branches. We label them branch 1 and branch 2 in our physics notebooks. But the label on the paper is not a physical object in space.
The map is not the ground.
Just because you can write the words branch 2 does not mean a physical branch. 2 magically pops into existence.
This leads us directly to what the source calls the golden rule, the standard of invariance.
This is the intellectual core of the entire paper. If you take one single thing away from this deep dive, let it be this exact concept, invariance.
It sounds like a title from a superhero movie, The Invariant.
It totally does.
Yeah.
But it actually comes from Albert Einstein, right?
It does. This is the Einstein move. The author argues that to completely understand why many worlds fails, you have to understand exactly how Einstein succeeded.
Take us back to 1905 again.
When Einstein was looking at the concepts of space and time, he noticed a massive, glaring problem. Observers completely disagree on everything.
Like the twins we talked about earlier.
Right. If you are moving past me in a train, my yardstick literally looks shorter to you. Your pocket watch looks like it is ticking slower to me. We disagree on space. We disagree on time. We even disagree on simultaneity.
Whether two things happened at the exact same time.
Yes. So reality appears completely subjective. It is a total mess of perspectives.
Einstein could have just stopped there. He could have thrown his hands up and said, okay, that means reality is fragmented. You live in your space-time, and I live in my space-time. We have multiple subjective realities.
That would literally be the many worlds version of relativity.
Exactly. But Einstein did not do that. He was a deep believer in a single objective reality. He asked a much deeper question. He asked, what is the exact same for both of us?
What is invariant?
And he found it. The space-time interval. It is a specific mathematical combination of space and time. No matter how fast you are moving, or what crazy direction you are flying, or how weird your clock is behaving, we will both calculate the exact same space-time interval.
So the lesson from history is, when observers disagree, do not just assume reality is multiplying. Do not assume there are multiple times. Look for the underlying rigid structure that is not changing.
Variation reveals invariance. That is the ultimate rule. Variation is just a trick of perspective. The invariant structure is the actual truth.
Now let us weaponize this rule against the multiverse.
Let us do it. Look at the branches in many worlds. These separate worlds they talk about. Are they invariant? Do they objectively exist regardless of how you look at the math?
I am guessing the answer is a hard no, otherwise we would not be talking about it.
The answer is absolutely no. The branches depend entirely on how you, the physicist, choose to describe the system. Specifically, they depend on something called the system-environment split.
Wait, I always thought that split was completely obvious. I am the system. The room around me is the environment.
Is it obvious, though? Let us look a little closer at that boundary. Is the air molecule currently bouncing off your skin part of you? Or is it part of the room?
Well, it is outside my skin, so...
What about the photon bouncing off your retina right now? Is that part of the observer or part of the observed? What about the microscopic gravitational field of your eyelashes?
Oh, okay, I see. The boundary gets incredibly blurry.
It gets very blurry. And in the quantum math, you have to arbitrarily draw a line. You have to write down everything on this side of the line is the system, everything on that side is the environment.
But I can mathematically draw that line wherever I want.
You can. And here is the smoking gun that ruins the theory. If you move that line, even a tiny microscopic bit, the mathematical definition of the branches completely changes.
Hold on. So if I do the math one way, I get two distinct parallel universes. If I shift the decimal point or draw the boundary differently, I get what? 3, none.
You get a completely different set of branches. It also heavily depends on coarse graining.
What is coarse graining?
It is how blurry you make your mathematical view. If you squint at the math, the branches merge together. If you zoom in close, they split apart into a million pieces.
That does not sound very real.
It's not. Imagine if I told you, hey, there's a solid oak table in this room. But if you look at it from the left side, it physically becomes 2 chairs.
I would say it is a hologram, not a real oak table.
Exactly. If an object changes or totally disappears just because you changed your bookkeeping method, it is not physically real. A rock is a rock, whether I measure it in inches or centimeters.
If the rock disappears when I switch to centimeters, it was never a rock, it was a ghost.
So the worlds in many worlds are ghosts. They are artifacts of how we choose to write the equation. They are not rigid physical structures out there in the universe.
Correct. So applying the Einstein move here, the branches vary wildly based on perspective. So what is the invariant? What is the rock?
The universal wave function itself, the whole thing.
The single, unified, unbroken mathematical object. That object never changes based on your perspective. So the unavoidable conclusion is the universal wave function is real. The branches are just view-dependent patterns.
The text uses an amazing analogy of time zones here, which I found incredibly helpful for visualizing this whole mess.
Yes. Imagine looking at a flat map of the Earth. You see these strict lines dividing it into 24 time zones. Those lines are incredibly useful. They help us organize society, catch trains on time, schedule meetings across the globe.
But do those lines actually physically cut the Earth into 24 separate planets?
Of course not. If I drive across the border from Central Time into Eastern Time, the ground does not physically split open. I do not magically enter a parallel dimension where things are an hour ahead.
Does crossing a time zone line mean you have entered a parallel Earth?
No. It is just a conceptual grid we drew over a single sphere to help us measure the sun relative to our local position.
So the many worlds interpretation is literally like looking at a map, seeing the time zone lines and shouting, my God, there are 24 distinct Earths.
That is exactly the argument the paper is making, mistaking the index for the territory. The quantum branches are just coordinates on one invariant structure, not separate physical containers holding alternative lives.
That is really damning, actually. It makes the whole multiverse theory feel like a massive linguistic and mathematical confusion.
But these are brilliant physicists. Surely they have a robust defense against this. They must know about the system-environment split.
Oh, they definitely know about it.
Yeah.
They are not ignoring the math, they just interpret it differently. The text actually calls their defenses escape routes. And Section 4 of the paper is entirely dedicated to blocking all the exits.
Let us play devil's advocate then. I am a multiverse defender. I am completely desperate to keep my parallel selves alive.
Okay, defend yourself. Give me your best shot.
I say, okay, maybe the branches are fuzzy. Maybe they do depend on how you look at them. But look at a hurricane.
Okay,
A hurricane has very fuzzy edges. It depends entirely on how you define the wind speed. You cannot say exactly where the hurricane ends and the tropical storm begins down to the inch.
True.
But if a hurricane hits your house, you know it is profoundly real. It tears the roof right off. So
Right.
why cannot quantum worlds be like hurricanes? Emergent, fuzzy, but totally physically real.
This is the emergence defense. And honestly, it is their strongest argument. Physics is full of emergent things. Tables, chairs, the temperature of a room, none of them are fundamental particles. They are large-scale patterns.
So why is not a universe branch just a massive pattern?
The text brilliantly distinguishes between good emergence and bad emergence.
How is the exact difference?
Robustness. A hurricane is fuzzy, yes, but it is robust under transformation.
Meaning what exactly?
Meaning, if I mathematically rotate my map, the hurricane is still there destroying the house. If I switch my measurements from metric to imperial units, the hurricane is still there. If I describe the storm in Spanish or English, it is still there.
It survives the natural transformations of the theory. It is incredibly stubborn.
It fights back against changes in perspective.
It fights back. But quantum branches. Branches are not stubborn at all. As we just discussed, if you change the foliage...
How do you slice space-time into moments?
Right. If you change how you slice it, the branches can completely lose their definition. They dissolve back into the math.
So a hurricane is a real objective pattern in the physical data. A branch is just a pattern in how you arbitrarily sort the data.
Modeling context is not ontology. That is the absolute key quote from this section.
Say that again.
Modeling context is not ontology. Just because a pattern pops up in your specific, biased mathematical model does not mean it is a real physical object out there in the universe.
It is like seeing a face in the clouds.
Exactly. The face is emergent, sure. But if you walk 10 feet to the left, the face is completely gone. You would never build a fundamental theory of cloud people based on that transient pattern.
Okay, that solidly blocks the hurricane exit. That door is boarded up. What is the next escape route they try to use?
The probability problem. This is a famously huge headache for the Many Worlds camp.
This is the one that has always confused me personally. If everything that can happen does happen in some branch, what does a 50% chance even mean anymore?
Exactly. Probability usually implies some level of uncertainty. If the weatherman says there is a 50% chance of rain, he means, I do not know if it will rain or not. It is a statement of human ignorance.
But in many worlds, it will rain in one branch, and it will not rain in the other branch.
Right. Both outcomes physically happen. So there is no maybe. There is only yes and yes. So where does the 50% number even come from? Why do casinos still make billions of dollars if every outcome happens?
So how do the multiverse folks explain why I physically feel uncertainty when I roll a die?
Oh, they try to use the self-location defense. They say, okay, everything happens out there somewhere, but you just do not know which branch you are currently in.
It's like waking up amnesiac in a hotel with 1,000 identical rooms, and you just do not know your room number yet.
That is the exact analogy they love to use. You are in some branch, you just do not know which one you are occupying.
I mean, that sounds fairly plausible on the surface.
It does, until you look just a little bit closer at the definitions. To be located in a specific room, the room has to have solid walls.
And we just spent 10 minutes establishing that the walls of these branches are completely flimsy and subjective.
Exactly. This is called the individuation problem. You cannot logically say, I am in branch A, if branch A is not strictly defined by the fundamental physics. If the boundaries of the branch are completely fuzzy and dependent on your description, then being inside it is a mathematically meaningless statement.
It is like saying, I am currently located somewhere in the cool part of town.
Right.
Where exactly does the cool part end? Does it end at the independent coffee shop, or does it end at the dive bar down the street?
It is a subjective opinion. It is not a GPS coordinate. You cannot base a fundamental theory of reality on the cool part of town. If the room numbers are not permanently written on the doors by the actual laws of physics, then self-location is just a cheap word game.
Okay, probability is a total mess for them. What is the last escape route we need to board up?
The space-time dilemma, this is the really heavy artillery in the paper. The author sets a brutal logical trap with two horns.
I do love a good logical trap.
Horn A, space-time is fundamental. Horn B, space-time is emergent. Let us force them to choose.
Let us take horn A first. Space-time is real and fundamental. It is the solid stage the universe dances on.
If space-time is fundamental, then to have physically separate many worlds, you literally need many physical stages. You need to physically generate brand new manifolds, brand new expanding fabrics of space, every single time a tiny electron spins.
Does the math of quantum mechanics show us how to grow a brand new universe like that?
Absolutely not. The math only gives you algebraic separation.
Explain the difference between algebraic and geometric separation.
Algebraic just means writing a list on paper. I can easily write a list of coordinates, 1, 1, 2, 2, 3, 3. That is algebra. Geometric means actually going out and building a brick house at those coordinates.
Okay, I see.
The Schrödinger equation just gives us the mathematical list. It separates the terms algebraically on the chalkboard, but it provides zero physical mechanism for building the house. It does not tell you how to magically create the space, the immense energy, or the actual geometry for a brand new universe.
So if space-time is fundamental, the multiverse theory is basically magic. It just pulls infinite universes out of an empty at.
Right. It violates basic conservation again. So realizing this, they usually try to jump over to horn B. Space-time is emergent. This is the very trendy new idea in physics, right? That space is not a stage. It is built out of quantum entanglement.
Yes, things like tensor networks and holography, the idea that space is just quantum glue.
Exactly. But here is the massive problem for them. All those theories, every single working mathematical model we currently have, derives exactly one single geometry from the quantum state.
Gee, just one.
Just one. They show how entanglement stitches together a single cohesive spacetime. There is no model anywhere in modern current physics that shows how to mathematically stitch together billions of completely disconnected spacetimes from one single state.
So there is literally no map from the math to multiple independent spacetime.
Nowhere. So whether spacetime is fundamental or whether it is emergent, many worlds cannot find a physical place to put all its infinite copies.
It is rapidly running out of real estate.
It is a homeless theory.
Wow. Okay, let us take a breath. That was a huge amount of material. We have fully deconstructed our intuition. The time container is gone. We have looked at the invariance problem. The branches are just mathematical ghosts. And we have blocked all the exits. Emergence, probability, and space-time all totally failed to save the theory.
The many worlds theory is looking pretty shaky at this point.
Shaky. It looks like smoke and rubble to me. But we cannot just destroy things on this show. We have to build something new. That is the rule of the deep dive. If the universe is not a constantly branching tree of infinite copies, what is it?
This brings us to section 5 of the paper, the alternative, the one invariant structure.
The source points heavily to something called relational quantum mechanics, or RQM for short.
Yes. RQM, developed largely by the physicist Carlo Rovelli. This is basically taking the Einstein move we discussed earlier and applying it totally and ruthlessly to quantum mechanics.
How does it actually work in practice?
It starts by forcing us to accept that there is no God's eye view of the universe. There is no absolute view from nowhere looking down on everything.
Okay, so absolutely everything is a view from somewhere specific.
Exactly. RQM states that a quantum state is not a hidden property of an object in isolation. It is purely a description of a physical relationship between two interacting systems.
Give me a solid analogy for that.
Velocity, speed. If I ask you right now, what is the absolute speed of this book sitting on the table?
I would say it is 0. It is sitting perfectly still.
0 relative to you standing in the room. But relative to the center of the sun, that book is moving at 67,000 miles per hour through space. Relative to the center of the galaxy, it is moving even faster.
Right.
So does the book have a true speed, a secret, absolute speed number somehow written on its atoms by God?
No. Speed is purely a relation between the book and whatever observer is measuring it.
Right.
Speed only physically exists in the context of that specific relationship.
RQM says the exact same thing about quantum states. The electron does not have a defined state in itself. It has a state relative to you measuring it. It might have a completely different state relative to the other atom right next to it.
And that is okay. That does not completely break reality.
It does not break reality any more than velocity breaks reality. We are completely used to velocity being relative. We easily accept that stationary is just a limited perspective. We just need to get mentally used to state being relative in the quantum sense.
So how does this fix the massive many worlds problem we just tore down?
It completely removes the need for invisible, ghostly universes. You do not need to build a separate world for every single possible outcome. You just have a single, incredibly dense network of relationships in this one world.
It sounds deeply interconnected.
It is. It describes one single universe, densely and perfectly connected, where absolutely everything is defined purely by how it interacts with everything else around it.
And this brings us back to that incredibly beautiful, slightly terrifying idea of the block universe. The text gets very philosophical right here toward the end, almost mystical.
It really does. It returns to that thread analogy we touched on.
Identity is a thread woven strictly through the geometry, not a container hopping between fleeting moments.
Think about the coin flip from the very beginning of the show. In many worlds, that coin flip physically splits the universe. The you who sees heads goes down one timeline. The you who sees tails goes down the other. Your identity is permanently fractured.
Right, you are constantly being diluted, copied and pasted into infinity until your choices mean nothing.
But in the invariant structure view, there is absolutely no split. The universe is one solid, unmoving block of geometry, four-dimensional space-time.
The north of the North Pole thing again, the fully closed structure.
Imagine you could step outside of time, which we logically know is impossible, but just imagine it. The universe looks like a single, complete crystal, a complex, four-dimensional jewel holding everything.
Everything that ever happened, everything that will happen, is just a static facet of that incredibly complex crystal.
Like a mosquito perfectly trapped in amber. But the mosquito is the entire history and future of the whole cosmos.
And where exactly are we in that amber?
We are the threads running through it. Your life, your very consciousness, is a specific mathematical curve running continuously through that solid amber. You are not physically moving through time. You are just experiencing your specific thread sequentially.
There's a quote here I really need to read. It gave me absolute chills when I first saw it in the paper. It says, "What we call movement through time may be nothing more than the sequential reading of a text that was always already complete."
It profoundly changes the way you see your own life, does it not?
It really does. It makes me feel incredibly small, but also strangely permanent.
Permanent is exactly the right word. In a constantly branching multiverse, your life becomes cheap. If there are infinite versions of you out there making every possible choice, what does your specific choice today actually matter?
Yeah. If in another world I became a famous rock star, and in another I am a wanted criminal, and in another I am a silent monk, being me, right here in this room, feels totally arbitrary. It feels like I am just holding one random ticket out of a billion lottery tickets.
Exactly. It severely dilutes the weight of human existence. But in the one invariant structure model, there is only one you. There's only one path you ever take. Your specific world line is totally unique. It is woven firmly into the fundamental geometry of the universe forever.
It makes everything totally singular. The coin lands heads. That is it. That is the universe. No escape hatches.
One single outcome. One unified reality. One invariant structure.
So let us try to bring it all home. We covered a massive amount of ground today.
We really did. We went deep.
We started with a simple coin flip and a mind-bending paradox. We realized the paradox was only in our heads because we incorrectly thought time was a moving container.
We learned that MWI, the many worlds theory, basically tries to turn mathematical chalkboard labels into physical worlds, which completely violates the Einstein rule of invariance.
We saw clearly that the multiverse branches are just arbitrary grid lines drawn on a map, not separate physical territories you can visit.
And we finally landed on this profound vision of a relational universe. A single, perfectly interconnected geometric block where we are the threads actively reading the story.
It is a whole lot to process for one day. It definitely challenges the human ego. We desperately want to be the masters of time, choosing our own fluid adventure in a branching forest of possibilities. But the physics strongly suggests we are just readers of a book that is already perfectly written.
But hey, at least it is a really, really interesting book.
The most interesting one there is.
And, you know, there's one last thought that really hit me while I was preparing for this deep dive. A sort of final provocation for everyone listening.
Oh, I like those. What's the thought?
If the book of the universe is already completely written from start to finish, who wrote it? Or, to put it in completely physical terms, what exactly determined the final shape of that massive crystal geometry?
Oh man, that is really good. Because if we are not creating the fluid future step by step with our ongoing choices, then the solid geometry of the future is literally already sitting right there. Does that mean the future is somehow pulling us toward it?
Right? A teleology, a final purpose, physically built into the very shape of space-time from the beginning.
Maybe. Or maybe the strict human distinction between a cause residing in the past and a purpose residing in the future is just